So let's talk about the dot product. The dot product of vectors u equaling u1, u2, u3, and v being v1, v2, v3 is given by the sum of the products of the components. So what that means is I'll take the product of u1, v1, and that'll be here. I'll take the product of u2, v2, that's here. And I'll take the product of u3, v3, and that's what we have here. And what we'll do with those is we are going to sum them. And that's what that's saying. So we're going to add that up, and that's just going to give us a number. So there's another way we can also look at dot product. Dot product can be u dot v equaling the magnitude of u times the magnitude of v cosine theta. Now, when we just have two vectors and we're looking for the dot product, we just use this formula here. But when we want to find the angle between those vectors, that's where this formula comes in handy, over here. So depending on what we're doing, depends on what formula we're going to use. So now what we're going to do first here, this question down here says calculate u dot v and determine if the vectors u and v are orthogonal in each problem. So what we're going to do here is we're just going to calculate the dot product. So that simply means we're going to use this first formula here. Okay, so let's get started. So my u dot v, now what I'm going to do is I'm just going to rewrite these as a dot product. And we're just simply going to say that this equals, now I'm going to take 2 times negative 1 and that's the first one. I'm going to add that to 2 times 2 and then I'm going to add that to the last one, that is negative 1 times positive 2. Now I'm going to move this one around so I have room for the next one. So now this equals, and this is going to be a negative 2 plus 4 minus 2. And essentially that's all of these here. Okay, and then for our final answer for those, we get 0. Now the next part of this, we just calculated it. That's the first part we did, is we calculated. And the dot product of u and v in this problem is 0. Now the second part tells us to determine if the vectors u and v are orthogonal in each problem. So this is orthogonal because the dot product is 0. Anytime the dot product is 0, that tells us they're orthogonal, which simply means that these two vectors are perpendicular to each other. Okay, so there's problem A. So orthogonal. Oops. There it is. Okay, now for B here, this is an IJK form. So I don't have to, but I generally write it in component form because component form is just accustomed to. So if you're used to IJK form, that's fine. Or they call it unit form in this book here. So I'm just going to say 1, -3, and 4, dotted with 2, 2, 1. So this is going to equal 1 times 2 plus negative 3 times 2 plus 4 times another room there, 1. Okay, fit it in. All right, and this equals 2 minus 6 plus 4, which this also equals 0. Oh, these are boring. So both of them are orthogonal. Now, if I got any other number but 0 here, it would be not orthogonal. So this one also is orthogonal. So there's our problems.